Hello everyone! I hope you're ready for another adventure, because today, Wayne reads Dinosaur Mysteries. Always remember that as we go through these amazing stories and read these outstanding adventures, all you have to do is press the CC button in your YouTube link in order to follow along with the words. Now I think that Bumblebee will be perfect to join us for today's adventure. Now that Bumblebee's here, let's jump in. Dinosaur Mysteries, the cold-blooded mysteries. On August 2nd, 1841, a young British scientist stood for 2.5 hours reading a report he had written. He and his listeners were paleontologists, expert in the study of dinosaurs, and fossil bones were what the speaker, Robert Owens, was discussing. The bones belonged to a new group of very large and ancient land animals. Owen believed the creatures had looked like lizards, so he called them dinosaurs, or terrible lizards. No one had ever heard the word dinosaur before. At first, everyone mistakenly thought dinosaurs crept like lizards, low to the ground, as in the picture below. From the very start, people were fascinated with dinosaurs. Scientists themselves at the time did not have any answers to questions about the amazing creatures. They had not seen a complete dinosaur skeleton. They had seen lizards though. At first, they imagined that dinosaurs, like lizards, had sprawling legs and bellies that almost touched the ground, and so they believed that the bodies of dinosaurs must have worked in much the same way lizards' bodies work. For example, a lizard soaks up body heat from sources outside itself, from the air around it, or on a warm rock or the sun. When the weather cools off, so does a lizard. Its body loses heat. That is why lizards and other reptiles are said to be cold-blooded. They have no way of controlling their own temperature. When a lizard is cold, its heart slows down, and it can hardly move. In very cold weather, it crawls to a hole and waits for the air to warm up. If the cold spell lasts long, it goes into a long sleep. This is called hibernation. A lizard doesn't have a large supply of energy when it is warm either. It may hunt by sitting perfectly still, flipping out its long tongue at a passing fly, or it may suddenly dart at an insect. But soon afterwards, it'll flop on its belly, all worn out. For every minute a lizard spends standing up, it spends 9 minutes laying flat. Were dinosaurs really like lizards? Were they cold-blooded and inactive much of the time? At first, scientists thought so. Later, after many skeletons were found, it became clear that some dinosaurs must have marched nearly upright on hind legs. Standing on two legs means that most of the body's weight must be held off the ground. Even if the body is not on motion, the leg and back muscles are not resting. They must constantly at work, keeping the body's frame upright. So a big dinosaur that walks mainly on its hind legs had to use a lot of energy, even when it was standing still. Low-slung lizards do not have that kind of energy. To some scientists, it began to seem that dinosaurs were less and less like lizards. The experts studied not only huge dinosaurs, but the mini dinosaurs. A group of small bird-like creatures called coelurosauruses was especially interesting. Coelurosaur means lizard with hollow. These graceful creatures had delicate hollow bones, dainty heads, long curved necks, and very long legs. One of the smallest coelurosaurs weighed only about 2 pounds. It was called Saltopus, that is, leaping foot. Saltopus not only walked on its hind legs, but could run fast too. Its extra long shin bones and foot bones were made for taking long, springy steps, and it ran lickety-split on the tips of its toes like an antelope or a horse. Can you picture a small, swan-like body riding smoothly above feet, racing so fast they seemed to blur? That was how Saltopus must have looked. Could it have kept up with a swift pace for a long time? Scientists now believe that Saltopus and other coelurosaurs could, indeed, have done so. But if they were such swift, energetic creatures, they must have had bodies that were different from lizard bodies. Not long ago, a few scientists began to wonder about this. Was it possible that coelurosaurs are not cold-blooded like lizards? Could they have been more like the swift-moving antelopes, which are warm-blooded animals? An antelope doesn't have to warm up by the sun. Its own body constantly turns food into warm energy, the way a thermostat turns the heat on and off in a house. Suppose Saltopus had its own inside heating system. That would mean it was not just an overgrown lizard. And what about other dinosaurs? Suppose they too had been warm-blooded. Scientists who liked this idea began searching for evidence that might be correct. They took a new look at bones of such big dinosaurs. Sure enough, the skeletons of duckbills and some other dinosaurs show that they too must have been fast, energetic runners. This was one piece of evidence in favor of inside heating for dinosaurs as well as for saltopus. Another clue came from the duckbill dinosaur skeletons that were found far north in Canada. In that part of the world, days were very short in winter. The sun shines for only a few hours, and in some months there is no sun at all. Warm-bodied animals such like polar bears can live in cold, sunless country. Small, cold-blooded creatures might find deep protected holes for winter to sleep, but big cold-blooded animals could not stay warm enough with so little sun, or find big enough places for hibernating. This seemed to be a good argument for warm-blooded duckbills. Scientists got still another clue when they studied how animal bones grow today in parts of the world that have hot summers and freezing winters. They found that inside of cold-blooded bones resembles wood from pine trees, that they live in the same kind of climate. The trees grow quickly in summer, and a band of new wood is formed just under the bark. In winter, growth stops. Then it begins again in the next summer, and another band of new wood is formed. Every year, a new growth in the new ring is added. Summer growth rings can be seen in cold-blooded animals too, but the bones of warm-blooded animals have no such rings. What about dinosaur bones? Did they, like cold-blooded animals, show ring growths? They did not. Dinosaur bones resemble the bones of warm-blooded animals. For these and other reasons, many scientists now believe that all dinosaurs were warm-blooded. Others say that some had inside heating and others did not. A few people still stick to the old idea that all dinosaurs were cold-blooded reptiles. Probably experts will go on taking sides until more evidence for warm or cold blood can be found. Well, that was really cool, learning about the different types of warm-blooded and cold-blooded animals. What did you think, Bumblebee? I like that part too. We'll see you in the next time, okay? And we'll see you in the next adventure, here with Wayne Reads. Thank you for joining us, and we can't wait to see you again. Bye-bye!